Now this is the whole gastrointestinal system of the pig. You can see here the tongue, then down to the inferior to the tongue is the esophagus. Then we can see here the stomach. Now the right side of the stomach, we can see the liver together with the gallbladder. Now attached to the left side of the stomach is the spleen. Now let's move on to the inferior part of the stomach, which is, you can see here the pancreas together with a pair of kidneys. Now we can see here the connection between the stomach and the small intestine. You can see here the large intestine and down to the anus. Now let us separate them for closer examination and to know about their structures and function.
You know what? I like it.
Now we'll begin with the esophagus. First, let's observe the outer structure of the esophagus. Notice its long cylindrical shape and its slowly elastic texture, allowing it to accommodate food varying sizes. Here we can observe the outer layer called the adventitia, which anchors the esophagus to nearby tissues. Notice its elastic, flexible structure which allows it to expand and contract during swallowing. Now let's make a longitudinal incision to observe the inner layers of the esophagus. We can see 4 distinct layers. The first layer is the mucosa. This inner lining is smooth and coated with mucus to protect against food friction and potential damage from rough or hard food particles. Next is the submucosa. This layer contains blood vessels, nerves, and mucus-secreting glands that aid in lubrication. Third is the muscularis externa. Notice the circular and longitudinal muscle layers. These are responsible for peristalsis, the wave-like contractions that propel food to the stomach. Lastly, the adventitia. The outermost layer secures the esophagus in place and protects it from surrounding structures. Let's also discuss how the esophagus works. When the food is swallowed, it doesn't simply fall into the stomach. The esophagus uses peristaltic motion, where the circular muscles contract behind the food bolus, pushing it forward, while the longitudinal muscles shorten the esophagus to reduce resistance. Now we'll examine the small intestine, which is responsible for most of the digestion and nutrient absorption. It is quite long and coiled. Now, let's examine the small intestine, the longest part of the digestive system. Measuring about 6 meters, it's divided into 3 sections. The first section is the duodenum, the first 25 centimeters where most chemical digestion occurs. It receives bile from the liver and digestive enzymes from the pancreas. The middle part is the jejunum, the middle section where nutrient absorption begins. The last part is the ileum. It is responsible for absorbing vitamin B12, bile salts, and remaining nutrients. The small intestine is specialized for absorption. Thanks to its circular folds, this increases surface area and slow down chyme for better nutrient absorption. Next is the villi and the microvilli. These are microscopic projections that further increase the surface area and allow for maximum nutrient absorption. The large intestine is about 1.5 meters long and is divided into: first is cecum, a pouch-like structure that connects to the ileum via the ileocecal valve. Next one is the colon. Includes ascending, transverse, descending, and sigmoid regions. It absorbs water, electrolytes, and vitamins produced by gut bacteria. Next is the rectum and anus. The rectum stores feces while the anus controls their release.
After the esophagus, we have the stomach. So the stomach is a J-shape and a muscular organ located between the esophagus and the small intestine. So as you can see here, this is omentum. Omentum is a large fatty tissue structure in the abdomen. It plays several important roles. It helps cushion and protect the abdominal organs, act as a physical barrier against infection. And it can store fat, and the omentum can also help in the healing of damaged tissues by promoting tissue repair. And it keeps the stomach in place. This is the fundus. The fundus helps in storing food after the food enters the stomach from the esophagus. So for the body of the stomach, and one of its function is it stores food and allows for the gradual mixing of food with the gastric juices.
Pancreas is a retroperitoneal organ located inferior to the stomach. It has both exocrine functions, producing digestive enzymes, and endocrine functions, regulating blood sugar via insulin and glucagon. The pancreas is located behind the stomach. It is pale, somewhat soft organ. It is located in the upper abdomen, extending from the duodenum on the right to the spleen on the left. It is a soft, elongated structure with a pale, lobulated appearance. As I examine the pancreas, you'll notice that it has somewhat lobular structure. The pancreas has both endocrine functions, producing hormones like insulin, and exocrine functions, producing digestive enzymes. The pancreas has three main parts: the head, body, and tail. The head is nestled in the curve of the duodenum, while the tail extends towards the spleen. Notice the lobulated texture of the pancreas. This is due to the acini, clusters of exocrine cells that produce digestive enzymes. The islets of Langerhans, which regulate blood sugar, are scattered throughout the pancreas, though they may not be visible without microscopic examination.
Next up is the spleen. The spleen is an organ located at the upper left side of the abdomen, and it serves a lot of functions related to the body's immune system and circulatory system.
The spleen is an organ located in the upper left side of the abdomen
and it serves several important functions related to the body's immune and circulatory system. These include, first, filtering blood. The spleen filters out old or damaged red blood cells and platelets from the bloodstream, recycling iron and other components for use in the body. The second is for immune response. It helps fight infections by detecting and responding to pathogens such as bacteria in the blood. It contains white blood cells such as lymphocytes that produce antibodies to fight infections. The third is storage of blood. The spleen serves as reservoir for blood, storing platelets and red blood cells, which can be released into the circulatory if needed, such as during times of blood loss. Last is removal of waste. It helps remove waste products from the blood, including certain breakdown products of red blood cells. In summary, the spleen plays a key role in blood filtration, immune function, and blood storage.
So we're gonna explore the liver. So the liver is the largest internal organ in the body. It has a smooth reddish brown appearance and is located in the upper right portion of the abdomen, right just under the diaphragm. So the liver has two lobes, the right lobe and the left lobe. So the right lobe is the largest part of the liver. It responds for many of the liver's essential functions, such as filtering blood, storing nutrients, and producing bile. Is located at the right side of your body, just beneath the ribs. This is the left lobe of the liver, so the left lobe is smaller and extends toward the left side of the body. It shares similar functions with the right lobe, just is less prominent in size.
Ayaw i-full ka to. Half full lang.
So this is the hepatic vein. It's a blood vessel that carries blood away from the liver and back to the heart. After the liver filters and processes the blood, it needs a way to send that blood out of the liver. That's where the hepatic vein comes in.
So now that we are done dissecting the other parts of the gastrointestinal system, let us proceed to the kidney. So let us first know what is the kidney. So the kidney is the vital organ in our body, primarily responsible for maintaining homeostasis by filtering blood and regulating various psychological process. So before we dissect the kidney, let us first know its external and internal parts. So for the external part, this one is the lateral margin. This right here is the medial margin, and this one is the extremitas superior. Right here is the extremitas inferior. And this one is the renal ileum.
So now that we are done identifying the external parts of the kidney, let us proceed to its internal part. But before that, let us first cut the kidney into half lengthwise. So let us cut here sa lateral margin.
So this right here, this one is called the renal cortex. Renal cortex is the outer layer of the kidney that plays a key role in filtering blood and forming urine. So this triangular region of the kidney is called the renal pyramid. So the renal pyramid transports urine from the nephron tubules in the cortex to the calyces, where it collects before moving to the renal pelvis and the ureter. So this part of the kidney is called the calyces. So the calyces collects urine from the renal pyramids and funnel it into the renal pelvis, eventually directing it to the ureter. So this right here is called the renal columns. So the renal columns separate and support the renal pyramids. They provide passageway for blood vessels, ensuring proper blood flow for filtration. Although they don't directly filter blood, they are crucial for the kidney structure and function. So this right here is called the renal pelvis. So the renal pelvis is a funnel-shaped structure in the kidney that collects urine from the calyces and channel it into the ureter for transport to the bladder.